Okay, so look at this question. Acceleration is given to be 4x, varying with position acceleration, and at t equal to 0, x is one object is at rest. You have to find the acceleration in terms of velocity. So just do try it out. Hopefully, yeah, you have tried it. You should have paused the video and tried it. Now I'm going to take this up for discussion. Now here, the standard way in which students generally think is, since acceleration is asked in terms of velocity, you will think of writing a equal to v dv by dx. So that is because on the right hand side already x is there. If you wrote a equal to dv by dt equal to 4x, you have three variables involved in this: velocity, time, and position. So instead, if you write a equal to v dv by dx and equate this to 4x, which is given in the question, you can take dx that side and you can integrate. This is the standard procedure. In fact, you do like this, you will get v in terms of x. Once you get v in terms of x, you know that x will be equal to a by 4. You can put it back after you solve this in it. You integrate and solve it, you will get one relation. In that, you put x equal to a by 4, you will get the relation between a and b. This is a standard way of doing. So you try to do the integration and get the answer. But while I was discussing this particular question in class, a student came up with a very interesting way of solving this particular question. So I'm just going to tell you what is that particular interesting way that the student came up with approaching this question for getting a in terms of velocity. Right, now first let us do it in the standard way. So we have v dv equal to 4x dx, integrate both sides. So v square by 2 will be equal to 2x square plus c. The integration of 4x dx becomes 2x square, and I'm adding the constant of integration. Now it is given that when x equal to 1, velocity is 0, the initial condition. Note that when object is at rest, the position is x equal to 1. So you substitute now. When v is 0, x is 1, so 2 plus c, c will be equal to minus 2, or we'll have v square by 2 equal to 2x square minus 2, or v square will be equal to 4x square minus 4. And this is vx relation. Now in place of x, you put a by 4, you will get av relation. So let's do that. So v square will be equal to 4 times, in place of x, we'll put a by 4, that is what is given in the question, minus 4, we got av relation. So we have, now we'll simplify it, v square equal to, so I need to square it, 4x square. And so v square will be equal to a square by 4 minus 4. So we'll have v square equal to a square minus 16 by 4, or we'll have a square equal to 4 v square plus 16, or we'll get a equal to square root of this. We can write it as 2 times root of v square plus 4. That is going to be av relationship. And now let me tell you what is going to be that interesting method that the student came up with. So this is the idea. So now look at this. In the question, it is given a equal to 4x, and acceleration velocity relation is required. So you differentiate both sides with respect to time. So you get dA by dt equal to 4 times dx by dt, differentiating both sides. And dx by dt is velocity. So we can write like this: dA by dt equal to 4v. Now we want to get rid of time and bring relationship between a and v. So now you multiply with dv on both sides. So when you multiply with dv on both sides, so you will get dv times dA by dt equal to 4v dv. The idea of multiplying with dv on both sides is the right side becomes 4v dv integrable form, and dv by dt becomes a. So left hand side becomes a dA integrable form, right hand side becomes 4v dv integrable form. It's a beautiful manipulation. So you will have a dA equal to 4v dv. Now integrate both sides so that you straight away get a av relation. Now, when you integrate both sides, you are going to get a square by 2 equal to 4 times v square by 2 plus c. Now, to find out this constant, you will make use of the condition that is given in the question, that initially you see when x equal to 1, velocity is 0. When x equal to 1, the object is at rest, v equal to 0. And also when x is 1, a should be 4 from the given condition of the question itself. So we can say that when v equal to 0, a should be 4. So if v is 0, a is 4, you can substitute it back in the above equation and get that constant. So a is 4, meaning 16 by 2, 8. V is 0 plus c. Now that c value will be 8, or we can write this as a square by 2 equal to 2v square plus 8, or a square will be equal to 4v square plus 16. The same relation that we get over here. Okay, so straight away you get it in a direct manipulation. It's a very nice way of getting the relationship.